I was on the live stream earlier today trying to refactor this code base to put the bits that handle variable scope into its own module. And I was having a bunch of issues with it. And I think most of my issues with conceptualizing it have to do with the type system and specifically how the module system handles the type system. However, I do have something kind of working in this eval file. And so I think to move forward, what I'm going to do is just implement the functions to ergonomically help with handling variable scope, but do it directly in this file. So I kind of dodge the issue of doing that in a different module. So for instance, the first thing that I need to do here is I want to be able to better define a global scope here. So all I have to do is say, okay, let global, what if I call this global scope? I don't know. Yeah, something like that. Okay. So now, actually, I'm just going to call it global. So now what I can do is just replace this all the way up to this pink curly bracket with global. There we go. And everything should still compile at this point. I have an issue with scope file. We're just going to comment that whole thing out. Okay. And what else do we have an issue with? Main. Oh, okay, this guy. Comment that out. Comment that out. All right, now it should compile. Nope, still no. This one. Okay, finally got it. Okay. So that's the first step. Now we have a way of defining global there. I think that I still need the parentheses there because this will try and apply eval_dec as a first argument to listed, or so we can do that. Perhaps a better way to do that would be this with a pipe. Still compiles? Yeah, okay. I don't know which way is better, but that has less parentheses. So, all right. So now the next thing is handling assignment and identification of a variable. So let's do assignment. So let's define up here. We'll say let assign, and here we're gonna take a scope and ID. Yeah, that actually looks correct. However, I'm going to make this a little bit better. And we're going to just do function and global block let's see. Okay, there we go. So that's an assign. I guess technically we could do a declare and an assign. Yeah. So we could do, this one says add, and then this one in assign says replace. So that's assign. Let's do declare. Declare will be very similar, but it will be, instead of replace, will be add. And the other thing that I have to change is that I want this one to actually return back the value. So let's see. Yeah. So here's an interesting thing to note is hash tables themselves are mutable. And what's kind of boggling my mind a little bit is I'm not returning back even a scope. Like let's say for this, whoops, this is still a sign. We're going to call this declare here. Declare. Declare. So here I'm going to then return back the value itself. Okay. Yep, takes A, B, and the scope thing, and returns back B. Perfect. That's what we want for a sign. Now, the interesting thing is, like, let's say I'm returning back the value here. I'm not actually returning back the scope that was passed to it. However, that scope has some state that has been modified. So whatever else still holds on to that scope, the data that that scope holds on to has been modified, even though the scope handle itself hasn't been. So, for instance, I'm starting off with this global scope here, and then I'm passing that along. Let's see the block statement, for instance. I'm passing that along to the next block here. And that new handle has this hash table that's still holding on to the previous scope. Anyway, it's just kind of a little strange to think about. But so now what we can do here is we can, instead of this, we can do declare. Actually, what we can do is something along those lines. Is scope the last thing it's supposed to take? Yeah, okay. Eval expression scope E. Okay, that is correct. Cool. I can see why, I don't know, let's say I probably want this one to actually be the last bit being passed so I can do piping correctly. But I'm just going to leave it as it is. That should be fine. So even still right now, this should still compile, I think. Yep, it does. Okay. So then we can replace assign with the correct assign here. And that should still work. Cool. Now identifier can actually be corrected. Now it's doing, right now it's doing the wrong thing, but we can actually correct that with the correct thing. All right, let's correct this identifier thing. So the problem with this one is it's only looking in the current scope. It needs to look up into its parent scope as well, all the way up until the top. So let's do eval, let's say eval identifier. We'll just do an eval ID. Okay. And now it's going to take, again, the scope, and it's going to try and do the find. But this also does raises a not found, so I have to somehow catch that not found, and if it's not found, look in the global scope. So I think I can do something like open up something like that, and we're going to parent okay, we're going to catch, let's see how we can do that in OCaml. Catch Okay. Because handling exceptions interrupts normal control flow, using them can complicate some tasks requiring strictly ordered and coupled processes. For these scenarios, the fun module of the standard library provides this. This function is meant to be used when something always needs to be done after a computation is complete, whether it succeeds or fails. Printing, runtime crashes, exceptions not raised. Here we go. Try with is what we want to use. Okay, so let's do try hash table dot find b id and with eval id parent. I think that's what I want to do. I think we can put that on one line then. Oh, okay, we got to make this recursive. Okay, what am I doing wrong here? Do I need to put this in parentheses? Nope, that didn't matter. Put this in parentheses. Nope, that doesn't matter either. Maybe it needs the line break. Oh, okay. It needs this not found thing. That's what it needs. Or raises not found. Okay. Okay. Alright. Now we can replace eval ID in this identifier here. Oh, beautiful. Okay. So if we've done this correctly now, we've fixed the issue of not looking in the previous scope. So let's move this line out there. And now, when it does hello plus b, it should look in the parent scope for the world. And it sure does. Cool. If I were to comment this line out, or remove it rather, we should still get an error. Yeah, let's just remove it. Whoops. Yeah, we do. Same. That's the error we're expecting. Exception not found. Now, this is where we really should have some better error handling, but that's the thing we want to accomplish there. So, all the evaluations is currently still happening in one file here. I'd love to be able to break this up at some point, but for now it's working, and I'm just gonna keep going with it. And it's actually not a whole lot of code either. It's only 64 lines of code at the moment. So let's take a peek at the next bit in the book, and maybe we can actually finish out this chapter here, because we now have covered scope. And yeah, actually that's the end of the chapter there. So then we get into control flow and such. So we should be able to do this. Let's give that a try. Let's make our print function actually print a line break also. So when we say, I guess it's the eval, isn't it? When we do a print, we're just printing the expression. But I want that print to also print out a line break at the end. Print string. Why do we have to do it that way? Concatenating. Is there a way to... Is there a string interpolation in OCaml? OCaml. Interpolation. I'm curious if there's a way to... ask Copilot about this. Refactor this code. Nope, didn't change anything. Okay. Print string. Print string is a built-in thing, isn't it? So I want at this point to print string and then plus a line break at the end here. So we're going to do that. Hey, there we go. That's better. And we can do that. That's fine. Okay, so let's take a look at what that code does here. We're defining global A, global B, and global C. Then we define an outer A and an outer B. And then we've done an inner A. We'll print A, we get the inner. We print B, we get the outer. We print C, we get the global. Then we print A, B, and C again. We get the A being outer, B being outer, C being global. Then we do A, B, C again, and we get global, global, global for all of them. Perfect. That's exactly what we're expecting. So scope is working as expected. Still don't have all the error handling in there, but that's fine for now. So let's take a look at some of these challenges here. The REPL no longer supports entering a single expression and automatically printing its result value. That's a drag. Add support to the REPL to let users type in both statements and expressions. If they enter a statement, execute it. If they enter an expression, evaluate it and display the result value. So yeah, that is missing from a REPL at the moment. I do actually have a REPL in here. If you don't pass a file, then we've got a REPL. So we can say something like print hello. Actually, I don't know if I can store state. Var a is equal to 1. Print a. Whoops. Let's try it again. Var a is equal to 1. Print a. Hey, it does work. Okay. But if I were to then just say a, it doesn't actually print the expression value. And of course it crashes if it gets any bad stuff. So array handling is not there either. Okay. Maybe you want lock to be a little bit more explicit about variable initialization. Instead of it implicitly initializing variables to nil, make it a runtime error to access a variable that has not been initialized to us or assigned to, as in var a or var b. Actually, I don't even know if that works right now. Let's try. Oops, that didn't work. Var a. Yeah, so I don't even have it in the Lexer to do it that way. I probably should change it. But, actually, what does the grammar look like for that? Let's take a look at the Lexer. We have a variable, no, not Lexer, parser. Variable identifier equals expression and then a semicolon. I thought that's what they had for variable declaration as well in here. Statements and state. Statements, print statements. Okay, we've done that. Parsing statements, executing statements, global variables. So then we have variable syntax, var declaration. Identifier equals expression. Oh, okay. So this bit isn't a question mark. I see, I see. So that's something I didn't implement in here. How would we implement that here? We can say a var declaration can I do something like that with a var declaration of instead of e there, I can give it nil. This variant expression is expected to have type expression. There is no constructor nil within type expression. There's no constructor nil. Oh, oh yeah, of course, because there is no nil in OCaml. So I have to give it some value. Was expected of type expression. Let's take a look at what expressions can be in the AST, I suppose. Expression. Assign literal identifier, bind up. I suppose we could just say or nil, right? And then here I'll just say nil. But now everywhere in my evaluator, I now actually need to handle that. So we have to add that to print ast, and there's no constructor boolean within type expression. Line 100. I don't know if that's an actual issue. It wasn't an issue before. Let's go to our print and say that in the case of nil, print string nil. That's fine. Oh, it's a literal. We have a literal of nil. Okay, let's undo all this. Let's go back to here. And let's make that let's change it in here as well. It's supposed to be an expression. We can make it a literal of nil. Literal nil. Hey, look at that. Okay, so now we can do var a. Nice. And then if we ask for a, nothing comes back out. If we print a, it's nil. Cool. That wasn't so hard. Okay, let's go back here. Go back to challenges bit. Oh, okay, so in this case, making a runtime error. Yeah, we could do that. What does the following program do? Var a is equal to 1, var a is equal to a plus 2, print a. What did you expect it to do? Is that what you think it should do? What does analogous code in other languages familiar? What do you think users will expect this to do? So let's give that a try, see what that does. Okay, so it gets us 3. So we have a starts off at 1. A is now redefined to 1 plus 2, and then we print it out as 3. So that's how I think I would expect it to work. It looks like at this point, okay, so here we have a variable declaration. Here we have another variable declaration. The semantics of variable declaration says first evaluate the expression on the right-hand side. When evaluating the expression on the right-hand side, we have an a. We need to look up what the value of a is. We do have a value for a. It exists in the global scope. We pull that value, we add it to 2, then we define it to this a, which now exists on the current block scope. Then when we print out a, that refers to this a, which is now 3. So I think that's what I would expect. I don't know of other languages that handle it differently than that, but I don't know. I'm good with that. Design note, implicit variable declaration locks as distinct syntax for declaring a new variable and assigning to an existing one. Some languages collapse those to only assignment syntax. Assigning to a non-existent variable automatically brings it into being. This is called implicit variable declaration and exists in Python, Ruby, and CoffeeScript, among others. JavaScript has an explicit syntax to declare variables, but can also create new variables on assignment. And Visual Basic has an option to enable or disable implicit variables. When the same syntax can assign or create a variable, each language must decide what happens when it isn't clear about which behavior the user intends. In particular, each language must choose how implicit declaration interacts with shadowing and which scope an implicitly declared variable goes into. In Python, assignment always creates a variable in the current function's scope, even if there is a variable with the same name declared outside the function. Ruby avoids some ambiguity by having different naming rules for local and global variables. However, blocks in Ruby, which are more like closures than like blocks in C, have their own scope, so it still has the problem. Assignment in Ruby assigns to an existing variable outside of the current block if there is one with the same name. Otherwise, it creates a new variable in the current block scope. CoffeeScript, which takes after Ruby in many ways, is similar. It explicitly disallows shadowing by saying that assignment must always assigns to a variable in an outer scope, if there is one, all the way up to the outmost global scope. Otherwise, it creates a variable in the current function scope. In JavaScript, assignment modifies an existing variable in any enclosing scope. If found, if not, it implicitly creates a new variable in the global scope. The main advantage to implicit declaration is simplicity. There is less syntax and no declaration concept to learn. Users can just start assigning stuff and the language figures it out. Older statically typed languages like C benefit from explicit declaration because they give the user a place to tell the compiler what type each variable has and how much storage to allocate for it. There's actually another advantage to that. Declarations, well, depending on the type of declaration, having declarations at the top of the file meant that you could parse your code in a single pass. You didn't have to do hoisting. In other words, you didn't have to look for definitions further down in the file and pull them up. Where were we here? Okay, in a dynamically typed garbage collected language, that isn't really necessary, so you can get away with making declarations implicit. It feels a little more scripty, more, you know what I mean. But is that a good idea? Implicit declaration has some problems. A user may intend to assign to an existing variable, but may have misspelled it. The interpreter doesn't know that, so it goes ahead and silently creates some new variable, and the variable the user wants to assign to still has its old value. This is particularly heinous in JavaScript, where a typo will create a global variable, which may in turn interfere with other code. JS, Ruby, and CoffeeScript use the presence of an existing variable with the same name, even in an outer scope, to determine whether or not an assignment creates a new variable or assigns to an existing one. That means adding a new variable in a surrounding scope can change the meaning of existing code. What was once a local variable may silently turn into an assignment to that new outer variable. In Python, you may want to assign to some variable outside of the current function instead of creating a new variable in the current one, but you can't. Over time, the languages I know with implicit variable declaration ended up adding more features and complexity to deal with these problems. Implicit declaration of global variables in JavaScript is universally considered a mistake today. Strict mode disables it and makes it a compiler error. And actually, the things that really fix JavaScript scoping issues are let and const. Basically, don't use var anymore in JavaScript. Var will define things in the global scope, not in the scope that you're in right now. Python added a global statement to let you explicitly assign to a global variable from within a function. Later, as functional programming and nested functions became more popular, they added a similar non-local statement to assign a variables in including functions. Ruby extended its block syntax to allow declaring certain variables to be explicitly local to the block, even if the same name exists in the outer scope. Given those, I think the simplicity argument is mostly lost. There's an argument that an implicit declaration is the right default, but I personally find that less compelling. My opinion is that implicit declaration made sense in years past when most scripting languages were heavily imperative and code was pretty flat. As programmers have gotten more comfortable with deep nesting functional programming and closures, it's becoming more common to want access to variables in outer scopes. That makes it more likely that users will run into tricky cases where it's not clear whether they intend their assignment to create a new variable or reuse a surrounding one. So I prefer explicitly declaring variables, which is why LOX requires it. So I think perhaps what's lost in this little discourse here is also the difference between being able to have no value during declaration. So the guard against declaring a variable that's already declared within the scope, I guess it's more of like, so if you smash those two together, assignment and declaration, you say, okay, when you assign, we also declare. It's more along the lines of when you declare, you always assign, right? If you do that, then you can still guard against the issues of letting the user know, hey, you might be shadowing a variable here. You can still do that. The reason why some languages don't require you to declare is they actually are requiring you to provide a value during declaration. It's not so much that they're not requiring you to declare a variable, they are requiring you to provide a value at declaration time. And the neat thing about that is, the benefits that he was talking about of needing, when during declaration you get some information about the value, like what type it is and things like that. You also get that information if you're assigning during declaration. So a lot of those problems kind of go away if you just don't have explicit declaration where the declaration could actually be to a nil value and then separately an assignment to that value. So next we're going to pick up in control flow. We'll pick this up another time and looking forward to it. This will be like conditional stuff and then logical operators, loops. Very cool. So this would be fun. And then the chapter after that is functions, and I think we'll have a pretty good idea of a language at that point. So control flow. Let's actually take a look at the table of contents here. Control flow, functions, resolving and binding, classes, and then inheritance. And then when we're done with that, we're done with the first part of the book, which is the interpreter. And then we get into a bytecode virtual machine, which even though that's not technically compiling to machine code, will give you a pretty good feel of how to actually make a compiler at that point. So the book is called Crafting Interpreters. So we're really very much doing an interpreter right now with embedding one language instead of another. But with a virtual machine aspect, we'll get the kind of an idea of how to do a compiler aspect as well, down to machine code. So I'm looking forward to that. I also have no clue if I'm doing any of this right. I am following along in the book from a conceptual standpoint, but not in terms of the code, because I'm using OCaml instead. And if you haven't already figured out by now, I don't know what I'm doing with OCaml. I know semantically how OCaml looks and operates and such, but I don't know the standard library. I don't know the idiomatic way of doing things. I don't exactly know how modules even work, things like that. So if any of you are watching this and would like to correct my existing code and tell me that I'm doing it all wrong, please do. What I do plan on doing is there are some implementations out there of the LOX programming language in OCaml. The one that I took a look at is even less of an implementation than I already have. So I haven't looked at it too much, but I just took a peek to see how much they've done, and it's not all that much. So anyway, this has been a fun journey so far, and I'm glad I finally got that scope thing working, because I think I've had 2 live streams so far where I attempted to fix it and completely and utterly failed. So between now and like the next time I stream, I might try and clean this up a little bit more and add some, at least think about how I'm going to do the error handling so that I don't have another live stream where I'm just dead air trying to figure that out again. So anyway, we'll see you in the next one. Bye.